Good morning to all. Today we will have a lecture on replacement model. Again, it is a part of EMR subject. These are the today's learning points. Here you will understand the replacement model, objectives, types, the replacement decisions, benefits, and some references. Here I have defined some definitions. Replacement can be the planning and execution for the effective replacement of existing resources. For example, roof or a boiler or group of assets. Then the reasons why there is a need of replacement. Here we will understand what are the reasons for the replacement. Here reasons will be these iteration, working conditions, technical factors, or financials. Due to these reasons, we are replacing our existing resources. For example, machine tools, vehicles, equipment, buildings. Second reason is efficiency of any machine or equipment is getting reduced. The reason will be deterioration with respect to time. Time to time, or day by day, our machine, our resource, our vehicle, our bike is getting deteriorating. It means life of that particular vehicle is increasing, but efficiency or performance of that product or vehicle is getting reduced. After that, maintenance cost or running cost may be increased with respect to time, and sometimes it is not affordable. And here we will use replacement model to find out more economical way to replace the existing equipment by buying new one. Here I have mentioned one example, that is motor vehicle. Already we had a discussion in previous point. Here we can define or we can give best policies for replacement so that organization will save their investment. Here we can calculate total cost of machine in years in any year equal to cost of machine minus scrap value of machine plus total maintenance cost in n years. This is the common formula used for the calculation. Types of replacement model. In this point, there are two types: breakdown maintenance and preventive maintenance. Under each, it is again defined individual replacement and group replacement. Group replacement and individual replacement. Individual means one by one can be replaced, or many resources are installed for long time period, but some time or after some time, one or maybe more than one components or products may be break, but individually we are replacing that breakdown or failures. But in group replacement, at a time we are replacing more than one items or failures. Here we will save some money, but here we will lose some money. First case with respect to time. First problem. Here cost of bike, initial bike cost is given, resale cost is given, and this is the table. Here 7 years are given, running cost and resale value is given. These values, these data can be used for next calculation. These years, average replacement year are 7. Total running cost is also given. Here we will calculate cumulative running cost. Resale value is also given. Here we will calculate depreciation by using these cost. Cost of bike is given, that is 3000. 3000 minus 2000, that is resale value is 1000. Similarly, we will do for 7th year, that is 3000 minus 300, that is 2700. Like this we will calculate depreciation cost. Next column, total cost equal to total running cost, that is cumulative running cost plus depreciation cost. 600 plus 1000 equal to 1600. Similarly, we will do calculations for these years. Last column, average cost per year in dollar equal to total cost divided by respective year. For this particular year, we will divide it by cost. 1600 divided by 1, that answer is this one. Second year, 2961 divided by 2, that is answer. Similarly for these years. Here we will observe this last column. Out of these average cost, which one is least? And that is our replacement cost. And that cost is 1300. We will replace our existing resources, our existing bike in 5th year or the end of the year. Hence, the bike can be replaced in 5th year. That is the decision by using this model. Second problem. Here, same thing is given. Initial running cost is given. Then here constant reaches a constant value of Rs 500. Determine the proper length of service before the machine should be replaced. That decision we have to give here. This is the given table. And here solution is service in year 5 years are given in problem. Running costs are this. Cumulative running cost, here we can add 1800 plus 0, 1800 plus 2200 plus 1800, that is 4000. Similarly, we will do for these years. Resale value is already given, that as it is we have written here. Depreciation equal to service cost minus resale value. Here service cost is given, that is 3500 minus that is resale value, this one. Here we will get this value. That 3500 minus this one, here we will get this one. Similarly, we will do for these years. Average investment cost per year in RS equal to depreciation divided by respective year. This is our depreciation. 1600 divided by 1, that is this one. The next 2450, this divided by this. Total answer is 1225. For third year, this one. For last year, 600. That is 3000 divided by 5, that is 600. Next column is average running cost per year is equal to cumulative running cost divided by respective year. Cumulative running cost we have calculated here, divided by 1, that answer is this one. Divided by this, 4000 divided by 2 equal to 2000. 6700 divided by 3, that is this one. Similarly for 5th year, 13600 divided by 5, that answer is 2720. Then last column, average cost per year in RS equal to average investment cost plus average running cost. Here we will add these two. Final answer is this one. Next, this. Like this, we will calculate for these years. Then we will observe this last column. Here we will find out least average cost per year. Which is that least? That least is 3200. Here we can observe 3200. It means here our decision will be we can replace this or we can do some maintenance for this particular machine or service in third year or at the end of the third year. Third problem, same thing, but here some difference is there. That is maintenance cost in RS is given. Here we will do average years are 5 years, that is given as it is we are copied here. Cumulative running cost in RS, these are the cost. Cumulative running cost is, that is maintenance cost. Then depreciation cost is same for these years. 9000 we can copy as it is. 9000 is given, that is machine initial investment cost. Total cost equal to cumulative running cost plus depreciation cost. These things can be added. The new answer will be this one. Similarly, we will do some calculations for these years. Last column, average cost per year in RS equal to total cost divided by respective year. Total cost is this one. 9200 divided by 1 equal to 9200. Similarly, we will do for 5th year. 30,000 divided by 5 is 6,000. Then our decision will be same, similar decisions can be taken here. That is, best value is this one. Then hence the machine can be replaced in third year. That is our final decision based on this database. Group replacement. Previous problems were there on individual replacement. Here it is group replacement. It means more than one atoms or failures can be replaced in a replaced number of atoms can be replaced more than one. That is group replacement. That is I am trying to explain. Here first problem is, here whole thing is given, group individual replacement cost is given, group replacement cost is given. Then factory is also has installed. Initially they are installed 1000 bulbs, and this is the given probabilities, that is cumulative given probability for this particular problem. Then first of all we will calculate for individual replacement, then we go for group replacement. Individual probability we are calculated 0.10 divided by 0, that is 0.10. Then 0.25 minus 0.10, that is 0.15. Then we will do for these years. These are the probabilities, individual probabilities for that respective year. Then life we can calculate here. Life equal to time into individual probability. Life is 1 into 0.10, that is 2 into 0.15, that is 30. Likewise, we will calculate for these years. Mean life equal to 3.45, and individual failure per week is 289.9. Here I have written formula. Individual replacement cost is $869.6. Here we will compare the things. Group replacement is probability. Here we have arranged in tabular form. These are the years and these are the years. Here 0.10, that is already it is given 1000 out of 1000. 0.10 is probability, that is 100. 100 is for first year. For second year 1000 into 0.15, that is 150. And this previous one, this 100 we are using, 100 into 0.10, that is 10. For third year the 1000 into 0.25, that is 250. The next 100 into 0.15, then 160 into 0.10. Similarly, we will do calculations for these years. Then total cost and replacement cost we will calculate here. Total bulbs fail, we are calculated here, and these things are used here. Cumulative failures we have calculated like this: 100 plus 160, that is 260. 260 plus 281 to 541. Then individual failure cost is given, that is 100 into 3, that is 300. Group failure cost is 1000 into 1, that is 1000 is constant for group replacement, and cost is given 1 rupees. Total cost is calculated by using this, that is 1300. And similarly for these years, our average cost equal to TC by week, that is total cost we are calculated divided by weeks. First week 1300, and for second year 1780 divided by 2, that is 890. Similarly we will do for these years. Here decision is, cost of individual replacement is 869.6, and the second policy is 863. Group replacement is 863. Policy 1 and policy 2. Out of these two, which is least? This one is least. Means policy 2 is better for the replacement. Means group replacement is better as compared to individual. Then second policy is the optimum replacement policy. Like this, we have to take some decisions for the replacement of the existing resources, or group replacement or individual replacement. These are the benefits if your replacement model implemented in your organization. These things will be achieved in your organization. These are the references I have used for this preparation. You can also use for these problems or concepts of theories. If you have any doubt or question, you can ask me, or you can contact me on phone, WhatsApp, email, Google, Classroom, etc.